everyone, today we are going to be continuing to talk about the unit circle. Before I get into the notes too far, it is going to be important that you have everything all on one unit circle at this point. So if you have not had the chance to put this all together in one place, I do encourage you to pause the video right now. You can copy the one that's on the screen and get everything in its place. We're going to be using this unit circle, and we want to make sure we have everything available to us. So, in the last couple of videos, we've talked about radians, degrees, and all of our coordinates. We've talked about where sine and cosine are on this graph. But the one thing we haven't talked about yet is where tangent is. And you might be thinking if sine is on here and cosine is on here, tangent should be on here as well, which it is. It's just not quite as obvious as the other ones. So, let me grab my triangles here. We'll start with our 45-degree triangle. Now, I realize this circle that I'm using is not the one I originally used with these triangles, so it doesn't quite fit, but imagine I just shrunk my triangle a little bit. The sides are going to still be the square root of 2 over 2 for both of these. So if I'm working with my angle here in the middle, if I do tangent, my tangent is going to be the square root of 2 over 2, the opposite side, divided by the adjacent side, which is also the square root of 2 over 2. So I'm going to make just a little note of this down here on the bottom. If I was doing tangent of 45, that's going to be the square root of 2 over 2 divided by the square root of 2 over 2. And when I do that, I have the same thing on top and bottom, which we know anything divided by itself is just simply 1. So what I'm going to do is right below these coordinates here, you can see I actually whited out the answer already. But I'm going to say that tangent is 1. Okay, now that's the easy one. Let's talk about some of our other ones here. So if I go to my 30-degree angle, okay, this one I'm going to have 30 or the tangent of 30. This on the bottom here, tangent of 30 is again going to be my opposite divided by my adjacent, which is going to be 1/2 divided by the square root of 3 over 2. So let's go ahead and write that out. Now, a couple of things here. The dividing by 2's, because I have it in both of them, I can actually drop that away. And so this is the same thing as 1 over the square root of 3. However, if you remember back to when we talked about our exact values, we do not want our square root of 3 to be on the bottom. And so what we're going to do is we're going to multiply by the square root of 3 on top and on bottom. Okay, when I do that and go straight across, I get the square root of 3 on top. Square root of 3 times the square root of 3 means I'm squaring it, cancels out the square root, leaves me with just a 3. So up here for 30, we're going to say that tangent is equal to the square root of 3 over 3. Okay, last one I should do is going to be tangent of 60. So I got room to squeeze this one in. Switch out my triangle here. So it'll look like this one. So my opposite side is now the square root of 3 over 2. My adjacent side is the 1/2. So this is going to be the square root of 3 over 2 divided by a 1/2. When I do that, again, my 2's drop out, and this is simply the square root of 3 over 1, or I don't really need the over 1. I can just say the square root of 3. So tangent of 60 is going to simply be the square root of 3. All right, now, let's talk a little bit about what we're actually doing here. Now, I've shown you this with the triangles, and so you can see kind of where those sides are. But if I take the triangles away and I start to look at the patterns that I have here, say if I do 30 degrees, I'm going to ignore 45 because my two are the same. But if I look at 30, what I'm doing is I'm taking my y-coordinate and I'm dividing it by my x-coordinate. Okay? And we know that these correspond to sine and cosine. So what we say a lot of times is that tangent is simply the sine value divided by the cosine value, or you can think of this as the y-coordinate divided by the x-coordinate. Okay, and I can see that if I bring back my triangle here. If you remember back to how we got these coordinates in the first place, my y-coordinate is that sine value because it's 1/2 over 1, and my tangent value is the same thing, just the cosine value, the x-coordinate. So that's going to help us find some of our other tangents as well. Let's quickly do a couple of the main points, and then I'm not actually going to fill in all of the tangents just because it gets a little bit cluttered. I'm going to basically fill in this first quadrant here, and then we'll talk about how we can take it to the others. So let's start over here at 0. Now that I know that my tangent is simply y divided by x, over here at tangent, or at 0, this is going to be 0 divided by 1. Well, anything divided by 1 gives me anything divided by 1 or 0 divided by anything is going to be 0. Okay, and so I end up getting the tangent of 0 here. That one's pretty straightforward. The hardest one, I think, is going to be up here at 90. I'm going to actually write this one out a little bit. So tangent of 90 is going to be your x coordinate, or your y coordinate divided by your x coordinate. So 1 divided by 0. Now there's an issue here, because if you remember in math, we're not allowed to divide by 0. If you try it in your calculator, you're going to get an error. Okay, we're not allowed to do that. And so we have a phrase for when that happens, and we say that it is undefined. Okay, so that undefined is what we call the tangent of 90 degrees. If you go on your calculator will give you the same error when we do tangent of 90. So if I do it here, tangent of 90, get domain error. Okay, basically I can't do it. Or I can do 1 divided by 0, and I get an error that says I can't divide by 0. So slightly different errors, but either way, I'm not allowed to do it. Okay, so now I have all my tangents, or at least in my first quadrant I do. Let's talk about how we can go to our other quadrants. Just like I talked about my coordinates here, I'm going to talk about the values of tangents and whether they're positives or negatives. So in the first quadrant, tangent is still positive. All 3 of our trig values will be positive in that first quadrant. Okay, but when I go to the second quadrant, I know I'm going to take the y coordinate and divide it by the x coordinate. So it's going to be a positive divided by a negative. Well, a positive divided by a negative means that I'm going to end up with a negative. And when I go down to quadrant 3, I have 2 negatives, and a negative divided by a negative ends up making it positive. And finally, quadrant 4, I have 1 negative, so tangent will be negative. Okay. At this point, we're going to follow really the same patterns that we used before. So if I asked you something like the tangent of 210, okay, what I would do is I would say, well, I don't know this value exactly, but I do know my answer is going to be positive. So what I'm going to do is I'm going to go either straight up or straight across and try and get over here to my first quadrant where I can go. Well, if I go straight up, I go to 150. If I go straight across, I go to 30, and my tangent is the square root of 3 over 3. So that would be my answer. I can also go across first and then up. I still end up at 30. Tangent of 3 is square root of 3 over 3. Okay, so what I'm going to do is I'm going to bring in my other notes paper here, and we're going to try and find some of these tangents and work through these. Okay, so first one's tangent of 45. That one I gave you just kind of as a quick one. If I go over to 45 here, we already said that tangent is 1. So my answer here is going to be simply 1. If I go tangent of 360, well, we know 360 and 0 degrees are the same. So that's this point over here. My tangent is 0. Yeah, that's the last easy one. Now I'm going to go to 240. Well, 240 is down here in the bottom left. I can go straight across and straight up, and I end up at 60 degrees. Okay, that means I have tangent is going to be the square root of 3. And the one thing I have to verify is my sign, which it is still positive, so I'm good to go. Okay, next one is 5 pi over 6, tangent of 5 pi over 6. So I can do this with radians as well. Again, radians just get you to that place in a different way. So 5 pi over 6 is over here really at 150. So if I follow that straight across, I'm definitely at that 30 mark. So I'm using the square root of 3 over 3. But in this case, I'm in this upper left quadrant, and my tangent is negative. So I do need to throw in 1 negative there to make it a negative value. Okay, so now that you have your tangents, it's really the same as sine, cosine, and tangent, just knowing which piece of the unit circle you're using. I would encourage you to write in at least this first quadrant of tangents when you fill out unit circles from now on. Next thing we're going to talk about is what happens if we give you angles that are beyond the unit circle. What I mean is if you look at your degree measures, we know that we go between 0 and 360. Well, what happens if I give you an angle like number 1 here, where I have a negative angle? Well, that really goes back to what we started with when we created this triangle. We talked about, or created this circle. We talked about the fact that I'm measuring my angles by going up from this x-axis. This is my positive direction. The other way you can think of this is going counterclockwise around the circle. Okay, I can also go the other way around the circle, but now I'm going the opposite direction, and you might guess that I'm going to then have an opposite sign. So I'm going to have a negative angle. Now, just a quick note here, this actually goes back to our rotations. If you remember when we did rotations in class, we said that positive was the counterclockwise direction, negative was the clockwise direction. This is why, okay, just to be consistent with the unit circle. So if I say a negative 60 degrees, this is going to get a little bit trickier because I don't just go to 60, because I have to go a negative and then however 60 is. So we know 60 is kind of that bigger jump within one quadrant, not all the way to 90, but just one less. So if I'm going down here, I'm going to go all the way to 90, but then go back one. So I'm right here at 300. So really, this question here is the same thing as asking what is the sine of 300? Well, sine of 300 is my y-coordinate, which is going to be the negative square root of 3 over 2. All right, let's try another one just to make sure we kind of know what's happening here. So now I'm going to do a cosine of negative 315. So 315 is right here. So what that means is I've gone 3/4 of the way around the circle plus another half of a quadrant. So going the negative direction, I'm going to go 3/4 of the way around. It puts me directly at the top. And then an extra quarter puts me right here at 45. So I'm actually at 45 degrees. So this is the same thing as cosine of 45. And cosine of 45 is going to be the square root of 2 over 2. Okay. Number 3, tangent of negative 90. Well, 90 is a quarter turn, so I'm going to go the negative direction. That puts me down here at 270. But I don't have tangents labeled here, so I'm going to go directly across my circle, which actually puts me up here at 90 again, and we're undefined. Okay, so my tangent of negative 90 is the same thing as the tangent of 270, which means we are actually undefined. Running out of undefined. Okay. So those are your negative degrees. Okay. Let's quickly talk about number 4. Okay. Number 4, we have tangent of 480. Now the problem with this one is this one's actually too big. 480 is not a part of my circle because I only go up to 360. But what we can think is if I go 360 degrees around, I end up back here at 0. That's 360 of my 480. Well, then I have an extra 120 left. So I would end up here at 120. So this tangent is going to be the same thing as tangent of 120 because I go my full 360 plus an extra 120 to make up that 480. Okay, when I do that tangent here, I'm going to go across to 60 is going to be the square root of 3. Okay, but because I'm in this upper left, my tangent is negative square root of 3. Okay, next one, sine of 420. Again, I'm going to go 360 degrees around, which puts me here. But then I have to go an extra 60 degrees to get up here to the full 420. So this is going to be sine of 60. Excuse me, which is the square root of 3 over 2. And final one here, cosine of negative 510. Cosine of negative 510. Now I'm going negative, but I'm going more than 360. So I know I would go my full 360 around. Okay, and then I would have to figure out what I have left. Now this is going to start to get a little confusing. So I'm going to actually grab a calculator here. Negative 510. Okay, I'm going to say I did 360 degrees. So I'm going to add to it. Okay, it gives me negative 150. So I can go to 150 here. That's really just one less than going halfway. So if I go the negative direction, I'm going to be here at 210. So I'm going to say that my cosine here is actually at 210, which is going to be a negative square root of 3 over 2. Okay, so let's talk about what I just did there because this calculator thing that I just did can actually help you. So I was at negative 150 and then we kind of figured it out from there. But if I actually add 360 one more time, I get to the 210. Okay, and so what I want you to realize is that for these angle extensions is what I'm calling these angles that are not actually on the unit circle. Let me get this out of here for a second. You are allowed to add or subtract 360 as you please. Okay, and that's just going to do full laps around your unit circle, full kind of circles. So if I start anywhere on my unit circle, whether it's one of these coordinates or not, if I go 360 degrees around, I end up at the same place. If I go negative 360 degrees around, I still end up at the same place. Okay, and so the circular nature of this allows us to do that adding and subtracting 360 as much as we want. Okay, and so that's really what I would use to do these. The negative ones, sometimes they're easy enough that you can just kind of find where you're at. But if they get too far into the negatives, then you want to add that 360 like we just did on the last one. Okay. We can also start to tackle some of these things with our radians as well. So let's take a look at number 7 here. I have sine of negative 2 pi over 3. Well, 2 pi over 3, if I find out my unit circle is up here, it's really 120 degrees. Again, 1 past a quarter. So if I go the negative direction, I'm going to go my quarter, and then 1 past it, which is going to put me down here at 4 pi over 3. So this is the same thing as the sine of 4 pi over 3. And sine there is going to be a negative square root of 3 over 2. Okay, so really same idea, just using my radian there as well. Okay, I'm actually going to change these ones. They were not the ones that I actually wanted to put there. So let's do cosine of, let's just do negative pi. Okay, well, we know pi is halfway around our circle. So if I go negative direction around, I end up over here, and my cosine value is simply a negative 1. Okay, let's do a tangent as well. Let's do tangent of, let's go tangent of negative pi over 3. Okay. If I do tangent of negative pi over 3, well, pi over 3 is really that 60 degrees. It's 1 less than a quarter. So if I go my negative direction, I'm going to go the quarter and go back 1. So I'm down here at that's 330 degree, or 5 pi over 3. So this is really tangent of 5 pi over 3, which is going to equal my tangent here. If I go straight up, it's going to be at 60 degrees, so it's the square root of 3. And because I'm in this lower right corner, my tangent is negative. So I have a negative square root of 3 there. Okay, so just a few more examples of kind of using tangents and then extending our angles as well, going beyond 360 and 2 pi to find some other radians as well. Okay, just a quick note here. If you look at the ones that I crossed out, these were ones where we're above 2 pi, so you can go above 2 pi in the positive direction as well. That one's just a little bit harder because you got to kind of work your fractions down. So we're not going to do those this year, but we will do these negative radians that will show up on your circle.